Hi everybody, I continue the third lecture in the statistic. We could classify discrete distribution into several methods as a uniform and the binomial and Poisson distribution. In the binomial distribution, the experiment has two outcomes, and usually this outcome can be positive or negative, or success or failure. And the probability of success remains a constant p from trial to trial, which and then is very important in this type of the statistic method. We care about the success, and also we care about failure. The experimental is repeated n time. Usually it can be independently. It's very important. And then we can say about these three rules. And the binomial distribution we can show by the n and the k with the repetition time and relative frequency, and we can classify and we can success. Usually we care about success and we show k for the success, not for failure. And with the last lectures method, we can find new formula. And for this, and for the b is the binomial distribution for the a and k. We can find a new formula. It is equal to pk is probability of the k. Usually x equal k, and we can find with formula k is the for the success value which we use for the repetition. And as if you see here, and with this formula we can find the b is the p power k multiply q m minus k, which we studied last time. And we can use with the factorial formula for this situation, and we can find the success probability in the statistic method. For example, in a certain population of a particular disease have 30% probability. What is the probability time that in a sample with a sample size 10 and exactly 4 people have the disease? What is the expected value and what is the variance? It's very easy, and we can find with the calculation, and also we can find with the RStudio or SPSS. As you see here, we can case equal 10 value, and when we have a 10 value, is we can find the p in the graph x smaller than k, because the k is here is that we have a 10 number, and we can find in the calculation. As you see here in the graph, if we have n is the equal 10 and p is equal 0.3, and or we can plot the if you see here with a different method with again n is a 10 and p is 0.5, and if we increase the 10, n is 100 and p equal 0.5. What is the difference here is that the graph we can see if we increase the number of repetitions from n to 100, as you see here, the accuracy of the curve will be better, and the curve may be, and we have a more probability we can find more probability mass per number of the success is very important, because usually and if you see here, if we increase the p to the 0.5 from 0.3, in this case, as you see here, and the graph will be more symmetric and the bell shape, which we studied last time. And the third one, it is a Poisson distribution, or number of the rare event is very important. In the last method we studied the number of the success, which is very important for us. But in this method, distribution of the number of events occurring in a specific time period or in a fixed part of the space. Example, for example, the number of the blood cell seen in the microscope, or the number of the stars in the element of the space or sphere, the number of the resin volume in the fruit cake, and the number of the telephone calls in the arriving out of the telephone in the time interval. The Poisson distribution can be obtained from the binomial distribution with a large n with the product NP is constant. It's very important. NP is constant. Okay, and usually P is probably is low and in the repetition, and we therefore expect it applied process in the very large number of the event occur, but only very few have certain probability of interest for us. Usually in the large number of the trial but few success, we can calculate the Poisson distribution method. And as you see here, and we can see the probability power p power k and 1 minus p power n minus k. As you remember, we used the last time the fit formula p over 1 minus p. It's very important for these methods. And if you see here in the same method with RStudio, I can show you the Poisson distribution. For example, the k it is around 10, and if you see the curve mainly in the density function, you see it is the same of the last method. Again, as you see here in the Poisson method, if have n is 100 and the p is 0.05, but if we increase the n number, it will be more accuracy, and mean can be increased also. And it is some useful site for the studying statistic, which I use it usually for the random variance. You can use this site, or for the calculation we can use Calc, and also with RStudio you can RDR.io or publication papers we can see here, and also we can find it for the variance. And today we studied all, and we can review the questions. What is the experiment and event? We study about it, and operation. I explained it. And what is the odd ratio, and what is the statistic sample, and what is the population, and what is the Poisson distribution and binomial distribution, and how we can calculate this situation. It is one of the important part. And for the calculation problem with these methods, we can find, for example, in the rolling disk, we can find odd ratio, or we can find a possible outcome and probability. And I think it is good for this time, and I have a great success for you, and thanks for a lot for this pay attention for this lecture. And next time we will continue the biostatistic in the other part. And thanks a lot. See you next lecture.